Hello students, welcome to the module number 2. Further we will continue the remaining topics, that is various thermodynamic process and extension of the first law to a control system, control volume. So let us start with the constant pressure process. So if you consider for any thermodynamic process, so between the state 1 and 2, for the constant pressure, you are heating the gas at constant pressure, then we have to find out what is the work done. So we know that from the constant pressure process, work done is W1 to 2 is equal to P V2 minus V1, because here the pressure is constant, only the variable is volume. As giving the heat to the gas, it start to expand, so the volume get increased. So the difference between initial state and final state that we are going to calculate, that is V2 minus V1. So if you want to calculate what is the heat, so that is according to first law of thermodynamics, we can write it as Q1 to 2 is equals to W1 to 2 plus U2 minus U1. So already we know that what is the work done, that is P into V2 minus V1 for the work, and internal energy is U2 minus U1. So the combination of these will get the heat transfer, that is U2 minus P2V2 minus U1 minus P1V1. This is the constant pressure process. See, you can observe here the arrow mark from left to right side, towards right side, means the gas is get expanded. So that is a constant pressure expansion process. If you are, that is a heating, constant pressure expansion means you are giving the heat to the system, that's why it is expanded. So other PV diagram is constant pressure cooling, that is you are removing the heat from the system, so it get compressed. So that is from right to left, arrow mark is moving from right to left. Okay, this is about the constant pressure process. Next, begin with the constant volume process. So here in constant volume process, as the gas expand, earlier case gas is expanded at constant pressure, but here if you take an enclosed cylinder or enclosed vessel, so you are giving the heat to the gas, so the container having a fixed volume, so there is no chance of increasing volume of the gas. So remain, and after heating the volume is remains same, that is V1 is equal to V2. So if there is no change in volume, we can't expect the work done. So integration of P into dV is P into V2 minus V1, but V2 is equal to V1, so hence dV change in volume is 0. If the change in volume is 0, the pressure into dV, that is 0, so what done is 0. So what about internal energy? Internal energy is U2 minus U1. So substitute this value in first law of thermodynamics equation. So Q is equal to H2 minus H1. So remember guys, so when you are applying a heat to the gas at a constant volume, so the heat transfer is change in enthalpy. Heat transfer is equals to change in enthalpy. Okay, next. Next, constant temperature process. It is also called as PV is equal to constant process. Constant temperature process is also we can call it as isothermal process. Isothermal means the temperature remains same before and after the process. Throughout the process, temperature remains same. Here, according to first law of thermodynamics, Q is equal to W plus du. Okay. So here what is Q? Q is already we know that the process PV is equal to constant. So Q we can write it as P1 V1 ln of V2 by V1, or if it is considered as a gas, that is M, that is PV is equal to MRT, that we can write it as MCV T2 minus T1. So here there is no internal energy, because internal energy is nothing but CV into T2 minus T1, here T2 minus T1 is nothing but 0, so internal energy is 0. There is no internal energy formed during constant temperature process. So whatever the heat is there, transfer is there, that will be a work done. So that we can understand by knowing this concept. Okay, next. Adiabatic process. Adiabatic process means here there is no um, change in entropy. That is PV to the power of gamma is equals to constant. So as gamma is nothing but it is an adiabatic index for the air. So if air is considered as a treated as a gas, then there is no change in entropy. So entropy means that is ds. So ds2 minus s1 is 0. So there is no friction, means if you consider piston cylinder arrangement, assume that there is no friction between cylinder wall and piston. So there is no heat addition or removal of the heat from the system. So Q1 to 2 is 0 during this process. Remember, so a constant entropy process or adiabatic process, the Q, that is the heat transfer, is 0. Okay, if the Q is equal to W plus du, Q is 0, then W is equals to U2 minus U1. Whatever the work done is there, that will be the internal energy. So that is how we can understand the concept and with mathematical expressions for the each process. Next. So final one is the polytropic process, that is PV to the power of n is equals to constant. So PV to the power of n is equal to constant means where n is a polytropic index, it is lies between 0 to infinity. So as n value changes, we will get the different process will be formed. So let us example, suppose if you consider P where n is equal to 0, the PV to the power of constant means at constant pressure process. We can see the horizontal line. Okay, so next if you n is equal to 1, okay, then it is a constant temperature process, that is PV is equal to constant. If it is n is equal to 1.4, so that is adiabatic index, so you will get the adiabatic process. So if the n is infinity, you will get the constant volume process or isochoric process. This is how you can find out in one process by varying the value of n. So this n is a polytropic index of the working substance. Okay, now for this again we are going to find out the what is the heat transfer. The heat transfer is nothing but Q is equal to W plus du. Here already we know the work done, so we can write it as work done and intrinsic combination, that is gamma minus n divided by gamma minus 1 into mr T1 minus T2 divided by n minus 1, or also we can write it as gamma minus n divided by gamma minus 1 into polytropic work done. That is also correct. So this is a polytropic heat transfer and the work done of this process. Okay, so next we'll discuss about the extension of the first law of thermodynamics to the control volume. So already you know that control volume is nothing but it is a fixed shape and position and orientation of relative to the observer. So example, for comparison and the difference between the control volume and closed system, I will clarify. So the both control volume and closed system are derived from the concept of boundary. Here what happened in closed system, the boundary may be usually a change in shape relative to the observer, but in control volume does not change, it is a fixed. That is what we are saying, the boundary may be fixed or movable or real or imaginary because of this reason only. So the boundary is that based on the boundary movement or fixing of the boundary, it decides the type of the system, the extension of the system of the extension of the system through the first law of thermodynamics. Okay, so this is about the all the contents of this first law of thermodynamics. So we will discuss further topics in the next video. Thank you.